So, kind of a quick review to bring us up to speed here. In working with identities, proving identities, you only get to work with one side, like we did in problem number 22 here, and like we're going to do in problem number 28 next. So the general guidelines are listed here. Write everything in terms of sines and cosines, factor out GCFs, use a version of the Pythagorean theorem. Those are all down here. We spent a little time deriving that, but unfortunately the video got lost. So let's pick it up with problem 28. We decided we were going to write everything in terms of sines and cosines, and it was a good decision because the sine term disappeared. We're left with 1 minus cosine squared. What's 1 minus cosine squared equal to? Sine squared. Woohoo! Sine squared of u. And that's where we can leave things. Because the left-hand side now equals the right-hand side. So we worked with just one side to get everything to match. So problem number 28 is kind of an example of this one right here, 28. And we also used a version of the Pythagorean theorem. So you can list 28 in a couple places here. No, not necessarily. No. Yeah, there's say again? You can't. You have to, in working with these things, you can only work with one side. So you can't add something to both sides. I know it looks true, and it is true, and it would be an identity, but it's a different identity, and when we're working with these things, you can only work with one side, which kind of limits us. It's unfortunate. Yeah, there's no debate on this part right here. Work with just one side. If you work with both sides, you'll make it easy for me to grade, if you know what I mean. All right. All right. Let's try problem number 40. Let's see. Cosecant of u minus cotangent of u equals the sine of u over 1 minus cosine, or 1 plus cosine of u. I gotta confess, when I was taking this class as a student here at OCC, I looked at some of these things and I just said, no way. I mean, this just looks so bizarre. I mean, who comes up with that stuff? But let me make you a promise. No matter how bizarre these things look, they will work out. They are challenging enough that I'm not going to give you something that won't work out, period. And a lot of stuff I'll give you is going to work out in a couple steps. So, okay. What side would you work with? Right side? Okay, let's work with the right-hand side. And if we look at our list of little things on the right-hand side, well, I don't see any square terms, so the Pythagorean theorem isn't looking good. It's already in terms of sines and cosines. Does anyone see anything? You got anything? Yeah, multiply by the conjugate. So let's do that. Now, you got to be careful. You can't multiply both sides of this equation by something, because you can only work with one side. So you have to multiply by something over itself. You have to multiply by a form of 1, and we chose the conjugate. So that's going to be 1 minus cosine of theta, or cosine of u, over 1 minus cosine of u. Okay. Let's see here. Does that help us out at all? Well, let me leave this as a product in the numerator. What happens when I multiply this out in the denominator? I'll get a 1 minus cosine of u plus cosine of u. And what are the last terms? cosine squared of u. Okay. Those two terms cancel each other out. So I'm left with sine of u times 1 minus cosine of u over 1 minus cosine squared of u. That's a terrible looking one. Okay. Any ideas from here? So there's something we can do from here? Change the bottom? All right, good. What would the bottom equal? All right, so sine squared of u. Cosine of u, sine squared of u. And that's pretty nice because we get a little cancellation here, right? One of those disappears. Now what I'm left with is 1 minus cosine of u over sine of u. And I think I'm looking pretty close here at this point. If I rewrote that as 1 over sine of u minus cosine of u over sine of u, then this side simplifies a little bit, right? What's it simplify to? Cosecant u minus cotangent of u. Wow, isn't that special? That's what I had to begin with. So I worked exclusively with the right-hand side, and I made it match the left-hand side, which is how these things have to work. Yes?
What if you make the wrong decision about which side you take? Like,
well, you can work.
Left side, and I realized, like, after like a couple of steps, I stopped. There's no way I'm not going anywhere. Always the case, or maybe I did something wrong. Or
Look, I mean, you know, it was earlier today. I was preparing for this lecture. There was one of the problems that took me a good 10 minutes to figure out. I kept on looking at it and I'm like, no, man, something wrong. I couldn't figure it out. I finally figured it out, but you know, what you're going to run into is what I ran into as a student and still run into is that sometimes the first thing you try doesn't work out. So just try something else. Okay. I am not, especially on an exam, going to give you something as hard as problem 72 was for me. Greg? All right, so let's see. Factor that, then what that would do is it would bring you back to here. It would so you do all this work, get down to here, and then you jump back up to basically where you started. So yeah, it would work, it would be okay, but you'd be doing this problem for a long time if you followed that path. You know, if something isn't promising, try something else. I mean, generally speaking, I think your intuition is going to be spot on that you work with the more challenging looking side. But, all right, well, tell you what, let's hush. Let me solve it from the left-hand side, okay? All right. So, a little impromptu here. Let's take a look at cosecant of u minus cotangent of u equals sine of u over 1 plus cosine of u. Suppose you chose the left-hand side to start with. You're like, nah, I always did these things on the left-hand side. I'm going to work with the left-hand side. That's fine. I guess what I would start with first is writing everything in terms of sines and cosines. So that would be 1 over sine of u minus cosine of u over sine of u. And then what could we do? Well, I've got a common denominator here. So sine of u. And, well, we could multiply by the conjugate of the numerator. Let's try that. So 1 minus cosine of theta over sine, or not theta, u, sine of u. Now, I'm multiplying by the conjugate of the numerator so that I'll get a squared term. And then I hopefully can use the Pythagorean theorem. So 1 plus cosine of u, 1 plus cosine of u. Now in the denominator, I'll leave those things factored. So I'll have, can we fast forward to this? It's just going to be 1 plus cosine of u minus cosine of u. They're going to cancel, so it's going to be 1 minus cosine squared of u. Not theta. Sine of u times 1 plus cosine of u. And you're right. This is sine of u, or sine squared of u, over sine of u times 1 plus cosine of u. And one of the sines cancels out, right? So, sine of u over 1 plus cosine of u. So we've done it with both sides now. Theoretically you can and should be able to do it with both sides, but I think practically speaking, choose the side that looks more difficult. Okay. All right, so good question. Appreciate that. Now what I've chosen for you is a pretty good variety of examples. Let's move next to problem number 46. Cosecant of v minus 1 over cosecant of v plus 1 equals 1 minus sine of v over 1 plus sine of v. Now, as the last one demonstrated, you can solve either side, work with either side. In this case, one doesn't necessarily look particularly much more difficult than the other one, but if you had to choose, where would you start? Left-hand side or the right-hand side? Left? Yeah. I mean, the cosecant looks a little bit more intimidating because it's not just a sine function, it's actually the reciprocal of something. So that actually gives you a place to start. Can anyone guess what we're going to do to begin here? Not quite the conjugate. 1 over the sine. And 1 over the sine. Now in your algebra classes, we call these things complex fractions. They're complex fractions because you have a fraction within a fraction. They're a fraction lover's nightmare, right? Fractions within fractions. Ugh. Now, yeah, you're a little premature there, but that's, yeah. All right. But thank you. Appreciate you being on the spot. So the thing to do with these things is to get rid of the extra fractions. I don't want a fraction here in the numerator and denominator. I've already got a numerator and denominator. I don't want additional fractions. The trick on that is to multiply everything by the LCD of these denominators. They're called secondary fractions. So the LCD for these secondary fractions, well, there's not a lot there. It's just sine of theta. So what I'll do is I'll multiply the numerator by sine of theta, or sine of v, and the denominator by sine of v. I have a feeling I'm going to be calling these v's and u's and x's thetas all day, but we'll work on it. Notice what's happening. I'm multiplying by something over itself. Effectively, I'm multiplying by 1. So I'm not changing the left-hand side. But I am going to make it look different. Let's distribute this to both terms. Katrina, what do you get when you distribute this to both terms, please? Wow. Oh, no way.
That's it.
That was easy.
There we go. Cool. That's it, right? Just one step and you're done. Left-hand side now equals the right-hand side. Cool. All right.
One steps on the test.
You know, there's going to be some easier ones. I'm not going to give you really hard ones on an exam, but we do need to practice some more. So let's take a look at problem number 52. Cosine of v over 1 plus sine of v plus 1 plus sine of v over cosine of v equals 2 times the secant of v. Wow. These things look like a real pain. What side should we work with? Left-hand side. Good. Start looking through your list. Does there look like there's anything promising? This is already in terms of sines and cosines. Doesn't look like there's a GCF. No squared terms. Does anything look promising? Anything at all? Anything looking good here? Oh, okay, cool. Yeah, get a common denominator. Let's try that. So, what would a common denominator be for problem 52 here? Perfect. It's just the product of these two terms. So, I'll take this term and I'll multiply by cosine v over cosine v. So, cosine v, 1 plus cosine of v. And this one's going to get multiplied by 1 plus sine of v over 1 plus sine of v. Okay, so this is going to give me one big happy denominator. Let me just write it all together as one fraction. Cosine of v times 1 plus this should be a sine of v. Thank you. Sine of v. Sine of v. Yeah, 1 plus sine of v. Now in the numerator, if I distribute here or multiply, I get cosine squared of v. Unfortunately, I'm not going to get a lot of nice simplification like I did in some of the other problems. I just got to FOIL it out. It's going to be 1 plus sine of v plus sine of v again plus sine squared of v, like that. Well, that's going to simplify. There's a lot of simplification in the numerator. Tell me what you see.
Sine squared plus cosine squared.
Nice. Let's take care of this one. Cosine squared plus sine squared is 1. All right, so I'll have a 1 there. 1. Is there anything else I can simplify in the numerator? Say again, what would that give me? It'd be sine v squared if I had sine v times sine v, but 2 sine v. And last but not least, 1 plus 1 is 2, so I get 2 plus 2 sine of v over cosine of v times 1 plus sine of v. Okay. Looking a little bit better there. Almost done. I need 2 more steps. Ah, yeah, one of our other things here, GCF. In the numerator, you can factor out a 2, which leaves behind 1 plus sine of v, cosine of v times 1 plus sine of v. I'm hoping that the last step is pretty obvious. Pull out your favorite Zorro pen, give it a little ole. You cancel that out. You're left with 2 over cosine of v, which is 2 times 1 over cosine of v, or better yet, 2 secant of v. And that's the right-hand side. Now, what would be more beneficial? You want to see a couple more from me, or do you want to try one? Or 2? Want to try one? Okay. Let me give you problem number 54, because there's a couple ways you can do number 54. So 1 minus sine squared of theta over 1 plus cosine of theta equals cosine of theta. So like I said, there's a couple ways you can work on this one. Work with a partner, work by yourself, whatever works, but give it a try. Keep in mind some of the things that are on our little list of things to try. No, it's not in the numerator. Let me be clear about that. It's 1 minus that. 1 plus cosine squared theta, e to 1 minus cosine squared theta. Right? It's not a plus. This is fine, but you be careful about how you cancel it. That's still out in front. The way that works is you have to factor this in. 1 minus this, plus this. And then you cancel like that, cancel like that, and one wrong. Okay, so I think we successfully proved one thing. These are challenging, right? Yeah, all right, good deal. So here's a couple different varieties of ways to solve this one. Let me start with this one, which is the approach that a lot of you went through. And that is, let's start by getting a common denominator. Now the common denominator, well, 1 doesn't really have a denominator, so the only denominator is really 1 plus cosine of theta. So I'll rewrite this as 1 plus cosine of theta over 1 plus cosine of theta. Great. Now these have a common denominator. Let's bring together the numerators. So all one numerator. But if you look carefully at this, then you've got a 1 here and a minus sine squared of theta. What's 1 minus sine squared of theta equal? Cosine squared, right? Cosine squared is equal to 1 minus sine squared. So I can replace those two with a cosine squared of theta. So let's do that. Of course, nice if I didn't. There it is. So, all right, here I rearranged it a little bit, make it a little bit more clear. But 1 minus sine squared of theta equals cosine squared of theta, which I've got down here. Still have the same denominator. Great. If you look in the numerator, though, there's a GCF. What's the GCF? Cosine of theta. So I'll factor out that cosine of theta. So cosine of theta times 1 plus cosine of theta, and wow, this and this look identical, leaving you with the cosine of theta, which is the right-hand side. Yay. So that's one possibility. Another possibility is this. And I think maybe one or two of you found this one. Let me start out by replacing sine squared of theta by 1 minus cosine squared of theta. I think you might have heard Terry talking about this earlier in the previous section, but this will factor. This factor is just like a squared minus b squared equals a minus b times a plus b. Factors into the product of two conjugates. This is going to factor just the same. Factors into 1 minus cosine of theta times 1 plus cosine of theta. Does that help me out? Absolutely. This thing cancels now. I'm done with my denominator. Oops, did I cancel the wrong one? Oh, man. Let's fix that. There, and 1 minus. Never happened. Thank you. All right, so 1 minus cosine of theta. And if you distribute the negative sign, you get 1 minus 1 plus cosine of theta, and the ones cancel each other out. So even faster. So multiple ways you could solve these things. It just takes practice. It does. I'm sorry about it. I wish there was a magic formula. I tried to give you as many hints as I could and as many examples as I could. Last one like the best? Yeah, the last one works out pretty nice. You're not always going to be that lucky to be so clever as to find the fastest way. Yeah, I did make that up special for you guys. I don't know where it is, but I'll see if I can find it. Remember a couple years ago I was proving identity in one of the other sections, and man, I just didn't see the right approach. And it took me like a page and a half. And I thought, man, my students will never get this. And then I realized, oh, wait a minute, I could have used this identity and I solved it in 2 steps. I was like, oh. So you're gonna struggle with this stuff, and I get it. On your exam, what I do to try and help you out and be fair is I'll give you 3 identities and I'll say prove 2. That way, if you're just beating your head up against a wall on one of them, then, well, you got an out, all right? So let me give you some homework, and then we'll take a quick break. Let's see. So for homework, try 21 through 65. Okay, good luck. Let's take a quick break.